I kind of forgot what's going on here. So, number 1. From a box 6 of 9, containing 3 red balls, 5 green balls, 2 balls are randomly picked, one after the other, without replacement. What does that mean, without replacement?
It means you're not putting them back.
Right.
Without replacement. Oh, this is the one where the number goes down.
Yeah. Did we do this in Algebra 2?
I think so.
I forget.
I don't remember it from Algebra 2, but I remember it.
Okay, draw a tree diagram showing the probabilities of each branch of the tree.
No. We know how tree diagrams work.
We don't like diagrams.
Burn them.
All of Algebra 1 doing the little.
You know, Matthew, this makes me very proud to be the number one cause of deforestation. Because these are the trees I'm cutting down.
Tree diagrams in Algebra 1.
No. No, not that kind of tree diagram.
Yeah. I know, but I just don't like the concept.
Okay, we can skip that. That's fine.
Yeah.
Okay, are the events second ball is red and first ball is red independent? That means, independent means the probability of one does not depend on the probability of the other.
No, they aren't independent because...
Right, they're dependent because once you pull the first ball out, you're not going to put it back in, so it's going to change the second. So B is no. They're not independent. C. Find the.
Did we do A?
No. Find the probability that both balls are the same color. So, how we're going to do this is figure out the probability that both balls are red. Add that to the probability that both balls are green. So, let's start with both balls are red. So, what's the probability that the first ball that we draw will be a red ball?
1 and 8.
3 and 8.
Have we done this before?
I think.
Because I remember this.
We must have done it Algebra 2.
I think we had.
I don't really
Or
remember
we've talked about it.
last year that well, but let's see.
So it'd be 3 and 8.
Oh yeah,
And
so
2
let's
and
say the
7.
first ball that you drew out was a red. What's the probability that the second?
2 and 7.
Right. So there's only 2 red balls left out of 7 in total left now. So this is the probability that you'll get 2 red balls, which is.
Wait, more.
Yes.
Why is it 2 and 7? Oh, because you don't have those.
Because the number of reds
So
went
it's
down by
6
1 and the
and
number of
6.
total balls went down by 1.
Why do we multiply?
The probability that 2 things happen together, you always multiply. We did a little bit yesterday, didn't we? No.
No, we didn't multiply.
I think I mentioned like if you flip a coin 2 times, it's like probability that you get.
That's 3 out of 28.
Anyway, that's the probability of getting 2 reds. That's not the answer. What's the probability of getting 2 greens? What's the probability of the first draw being green?
5 out of 8.
What's the probability of the second ball being green?
4 out of 7.
How are we supposed to?
So it comes out to 5 out of 14. So do we add that to the 3?
Yes. So this is the 2 reds probability plus the 2 greens probability. This is the total probability that you get
It's 13 out of 28.
2 of the same.
Wait, you do what to get the 13 over 28?
Add. You just did it on the calculator, but you could do it by hand if you multiply these by 2. That's 10 over 28 plus 3 over 28.
Was that C, Andy?
No, let's see.
Okay, they asked what's the probability that you get 2 balls of the same color. So I did what's the probability of 2 reds happening? That was this. green's happening, and the probability that either would happen is you add them together. Alright, C, find the probability that both, or D, find the probability that one is red and one is green.
And just 15 out of 28.
Yeah, so there is a way, the hard way to do that one is find the probability that the first is green and the second is red, kind of like that, Matt. And then what's the probability that the first is red and the second is green? And then you could add those, well, actually it's a little bit different. I lied. Probability the first is red, second is green, probability the first is green, second is red, and add those probabilities together, kind of like we did here. Or, if you think about it, this represents drawing two of the same color. So if you draw 1 and 1, that would be like saying not two of the same color, so not this. If you're drawing one of each. Does that make sense? So what's the probability that we won't get two of the same color? You do 1 minus this, which is 15 out of 28.
How do we get to 15 out of 28? Sorry.
Because 15 is.
Okay, 13 out of 28, that's the probability. That's the number of times in
Yeah,
28 that you get two of the same.
Okay.
So basically on D, what they're asking is, what's the probability that you get one of each? So which is like the opposite of saying two of the same.
What's less? Like 28 minus 13 is 15.
So in other words, the other 15
Oh,
draws,
okay. That's
the
how we
other
got it.
15 draws between these two
Is
would
the-
represent getting 1 and 1.
Oh, okay.
So it's not this. So you just do 1 minus 13 out of 28, which is 15 out of 28. So 15 is the difference between 28 and 13.
Okay.
We
I
tried.
think I got it, but just in case, so the whole thing again was listening.
Number 3. Number 3, let me peek at number 2. Repeat. Okay.
I like how number 2 is hard. Just do the same thing.
Do the same thing with different numbers.
Yeah. And they don't even have the capacity to write out the whole problem.
So we have to flip the page back and forth if we do.
Yes.
Really? It's not that hard.
You gotta remember, she's quickly, so.
I just thought that wasn't a bad thing to say.
You should
Hold on,
say
I'm
it.
confused. It says 1 red and 3 green. How can you have... Oh, yeah. If you only have 1 red ball, what's the probability of drawing 2 red balls?
0.
0.
I
It's
mean,
a curveball.
no, it's a red ball.
Okay. Repeat exercise 1 if the first ball chosen is put back in the box and mixed with the other ball.
Oh, now
So-
it doesn't go down.
You pull it out,
Easier.
you look at it, you put it back, and then you draw again. So you could potentially draw the same ball twice.
Wait, didn't you say 0 was the 3?
No, I was talking about number 2. On number 2, it says there's only 1 red ball. So I said, what's the probability that you draw 2 red balls? And that would be 0. So really, the only way that you could get 2 of the same color on number 2 is if you drew 2 green balls in a row. So you'd have to get, what's the probability of drawing a green and then another green? Anyway.
So it would be.
Number 3. Nope, not right now. Number 3. So we're going back to the 3 red, 5 green. And we're answering all the questions, but same questions, but we're putting the balls back. So 3B. Are the events independent of each other? Does the second draw depend on what happened on the first draw? No. They don't, it's not dependent, so it's independent. Does that make sense?
Mm-hmm.
Because we're putting the ball back, it doesn't matter what we did the first time, it's not gonna affect what happens the second draw. So for example, what are the odds of drawing a red ball? 3 and 8 on the first draw. What's the odds of drawing a red ball on the second draw? 3 and 8. So not affecting each other, the two draws, when you put the ball back. So 3B is yes, they are independent events, the first and second draw, because we are putting the ball back. C, find the probability that both balls are the same color. So we kind of just mentioned it, but what's the odds of drawing red and red?
388.
Times 388.
Oh,
What's
Wait,
the
I'm
probability
looking at
of drawing a green and a green?
5 over 8 times 5 over 8.
Okay, so what's the probability of either drawing two reds
you
or
add it together?
34 over 64. Those are decent odds.
over half?
I mean, I wouldn't bet at all, but you never know.
Okay, so D is what's the probability of drawing 1 and 1? So we use the trick that we used on number 1. Drawing one of each is the opposite of drawing two of the same kind. So
15 out of 32.
15 out of 32. Because 32 minus 17 is 15. Number 4, repeat 2. Okay, number 5. Two cards are dealt. Okay, back to a deck of cards. Two cards are dealt from the top of a well shuffled standard deck of cards. Draw a tree diagram.
No. For a deck of cards?
But not that kind of diagram. They're wanting an odds diagram. It's not like heads or tails, even odds kind of thing. It's kind of like that, but they use numbers instead. Yeah, maybe we should go ahead and draw it because we're only going 8. Alright. Two cards are dealt from the top of a well shuffled standard deck of cards. Draw a true diagram showing the probability of hard and non-hard. Okay, so I'll say, yeah, leave some room here. So H stands for drawing a heart, and N will be our non-heart. So what are the probabilities of drawing a heart?
3 and
1
4.
and 4.
I wonder why
Or 1 and 4.
Yeah. So, yeah, hearts, remember, 1/4 of the deck. So what's the probability of drawing a non-heart?
3
and 4. And what was the next thing it said? Are we drawing two cards? Yeah, we're drawing twice. So after that happens, if we drew a heart, then from there we could draw a heart or non-heart. Yeah, it is kind of like that. Heads and tails thing. Yeah. Okay, so what's the probability of drawing a heart on the second try? Still 1 and 4.
Wouldn't it change because there's less hearts?
Oh,
Where do they
are
reshuffle?
we putting it back?
I don't know.
I did read. Doesn't tell us.
Can we assume we're putting it back because it makes the fractions 1,000?
I assumed we would, but it actually doesn't say. Hold on.
I'll put the cards back.
You're gonna put it back. Make it easier if we put it back.
Yep.
Let's
It's like blackjack, but you didn't get dealt.
Well,
Put it back.
the stickers didn't give me an answer, so. Boo. Here, hold on, I can figure it out. Okay, they didn't put the card back. Alright,
But I
so.
put the card back, Mr. Jordan.
No, this is not that big a deal.
That's a
So
pretty good
instead
deal.
of 1 in 4 chance of drawing a heart, there's a 13 in 52 chance of drawing a heart. So let's say we drew a heart. What's the odds that the second card will be a heart? 12 out of 51. Because we're only down to 12 hearts now, and we're down to 51 cards. Is that right? If this is right, then the odds of drawing 2 hearts would be 3 and 51, 1 and 17. Yeah, that's right. Yep, that's what they did. Okay. So let's say we drew a heart on the first draw. What's the odds that the second draw would be a non-heart? How many
51 minus 12.
How many hearts would be left?
12.
12 out of how many total cards?
52.
No.
51.
Yeah, one
So
heart.
51 minus 12.
Sorry. Yeah, 51 minus 31.
39 over 15.
Okay, why did I use 39 instead of the 12? Because they're asking me how many chances for a non-heart. There were only 12 hearts left, but that leaves 39 of everything else. Out of 51. Okay, now let's go down the non-heart path. What is the chance of drawing? So there's 39 out of 52 cards are not hearts. Most cards are not hearts. So if I drew a non-heart, what's the odds that my second draw will be a non-heart?
38.
38 out of 51. We got one less of these, one less in total. It's down to 38 out of 51.
Is this supposed to be common knowledge to know how many cards are?
No, we talked about it yesterday. I mean, kind of is. Cards are pretty common, but you might not have known off the top of your head that there's 13 in each suit. So there's 39 in 3 suits and that kind of thing, but yeah. It's kind of common.
Maybe I should.
Just go play some stuff. There you go.
If you,
I never look at
if you play
details.
cards a lot, you'd probably know all that.
Maybe you should gamble.
Maybe
more.
we're just too Christian for the
Maybe we
since
should
this is
just
a Christian
gamble.
school.
You guys don't
What about
gamble,
Bill
no?
Knight?
Okay,
We had our own goat fish cards. We didn't
so let's say the first card was non-heart. How many hearts are left after that?
13.
13. We haven't used any. We haven't drawn any yet on this route. And how many total cards are left at this point?
50.
51. Because we drew one non-heart.
Do we have to go through another round, or is that it?
That's the picture. And we can, actually this is helpful because this is going to help us solve the B part really easy. Okay. I kind of thought I mentioned this yesterday, but then I realized a few minutes ago that we didn't. For 2 independent events to happen, that you want both things to happen, you just multiply those odds together. Okay, didn't we do this yesterday, I feel like?
No.
Like, what's the odds that you would roll a 5 on a die?
We used the graph.
5.
One
No,
and
Oh,
six.
that's right. Yeah, maybe that was why. What's the odds that you flip a coin and get a heads?
50-50.
1 and
1 and 2. What's the odds that both happen together?
I'm assuming so.
Okay, it's multiply, okay? If you want,
1 and 12, right?
yeah, if you want both events to happen, you just multiply. Or if there's 3 or 4 or 5 events, whatever, you just multiply all those events together, the odds of all those events together. That's what I was trying to show with the heads tails thing yesterday. When I drew that. Heads, that's a 1 in 4 probability. Tails, a 1 in 4. There's 4 outcomes with 2 flips. That's what the picture was for. Anyways, 1 and 2, 1 and 2. Blah, blah, blah. Alright, B says PHH. What do you think HH stands for?
Heart.
Hearts.
What's the probability that you draw 2 hearts is what that means. So how do we do it?
And multiply together.
1/4, use our little tree here. 1/4 times 12 over 51. Heart, heart.
I don't have a calculator.
You don't have to.
1 says
Right.
17.
Yeah, it does reduce to 1/17. Calculator definitely helped.
Did you do it in your head?
No.
What were you? I'm confused then.
Well, I probably didn't realize they reduced. Did you? Okay, so next one was probabilities of a heads, not head, or hearts, not hearts, I should say.
12 out of 60, or 13 out of 68.
Yeah, so hearts, 1 out of 4, not hearts, 39 out of 51. That would be this route. 1/4 times 39 out of 51. 13 out of 68. Okay, what is the probability that we'd get not a heart and then a heart?
13 and 68.
Yeah, it would be 3/4 times 13 out of 51. Happens to be the exact same thing as heart on heart. Do you guys see how I'm doing this?
Yeah.
Rachel?
Sure. I'm sorry, I've been kind of zoning out.
Okay, so just watch on this one, maybe you'll catch up. What's the probability that we get not a heart, not a heart?
You do 3/4 times 38.
Yeah, it would be this route right here. So
Alright.
first one would be 3 out of 4, second one would be 38 out of 51. Just multiply those two together. What does that come out to?
19 out of 34.
Now, if we add all these together, guess what they'll add up to?
1.
1. Because these are like the only 4 possibilities. So if you add them all together, it should add up to 1, like 100% of the puzzle. But I'm not gonna check that. Okay. Number 7. Took longer than I thought. Number 7. A card is randomly chosen from a standard deck. Show that the man's face card and diamond are independent.
Because taking a face card out won't affect how many diamonds are in the deck. And then the second one is a diamond could be a red card, right?
So show that the events red card and diamond
Red card?
are not independent.
What?
Draw one, you draw the other. The following 6 cards present 17.
This terror.
One card is randomly chosen. But events ace and heart. Yeah, it's tricky. Yeah, they didn't want us to explain it, but they wanted us to show the probabilities. Yeah, we'll probably just stop at 6, that's fine.
Yeah.
Yes.
Gonna be honest, my mental capacity this week has been negative.
This is like
2.
day 2.
That's because there's so many tests and stuff today.
All senior year, that's it.
I thought senior year was easy.
It's
Yeah,
gonna,
you just don't wanna do crap. That's where I'm at.
So
Yeah,
it'll
think
wait
if you had a full load.
Yeah, I have 3 classes and I don't wanna do anything, so.
where'd Brady go? Brady.
Oh, thanks, Nick.
Brady. Workload junior year. Doing everything required. Workload senior year doing everything required. Like it is